We are looking at lesson 78 today, looking at vectors. Vectors, you deal with them in geometry, you deal with them in pre-cal. They're not going away. Force vectors at a point. You use them in physics as well. You're going to use your vectors to represent a force. If it says 5 at 20 degrees, you're going to go out 5 at 20 degrees. It's going to be smaller compared to 25 at 40 degrees. 25 is going to go out a lot further. Resultant. Okay. So it says 2 ropes are attached to a point and pulled with the directions and magnitudes given. What is the resultant force on the point? So these are the 2 that they give you. Sometimes they'll just give you the picture and give you that information and not give you the 2. If it's on the board, I would suggest copying it, unless I say, do not copy this. Like this would be the picture. Sometimes they'll just give you the picture and say 2 ropes are attached and pulled as shown. And they won't tell you what they are. They just give you that picture. And you have to make it into the 2 vectors. Right, but sometimes they will just give you the picture. I don't have mechanical pencils. Alright, so how are you going to draw this first vector? What quadrant is that? Second quadrant? Do you agree? This is 70. What is my angle? Where'd the 45 come from? 180 minus 135. Does that make sense? You go 135 and you have 45 left? Yeah, this is 70. So you got your R and your U. Where would this one be drawn? First quadrant. What is your angle? And that's your R and your U. Your hypotenuse is 40. We've done this part before, right? You think you can find the resultant? You know what the resultant is? The result. What is? What is the result? What are you going to do? Add them together. Like you normally do. So all they're doing now is making it so that it's more of a word problem instead of just this plus this. Sometimes it will. Sometimes it won't.
Will it always be adding or will it subtract?
Resultant means atom. Yeah. Good luck with that.
How did they use that? Like,
They had a table, and they had to multiply. They literally had a table, and it would be like cosine and sine and tangent, and then for 0, 1, all the way down to whatever you need. And cosine of 0 is 1, 0, 0, I don't know, 0.9998, 0.0175, 0.0175. Huh? And they had a table like that. I don't know where they got the numbers to begin with. But yeah, that's why you want to use a calculator. Decimal form. Do you agree with that first vector?
Yes.
Okay. Any questions on those two parts? Okay, so putting the resultant force in rectangular would look like what?
R.
it's like that. Are
Okay, which would be? You see how that works? So that is rectangular, but it also said to do it in polar. How do we do it in polar? Okay, where do I draw it? My triangles are never to scale. That's just me. If you want to draw your triangles to scale, that's fine. I don't feel the need. My 14.86 is basically the same length as 69.5. That's just me. I don't draw them to scale. If you feel the need, that's fine. Yeah, since these are decimals that we're plugging in, I would put it as a decimal. I wouldn't leave it as the square root of 4900 or whatever it is. Do what? $71.07 is what I get for my H. 71.07. Yeah. You gotta take the square root of that. Yeah.
Yes, 71.07.
Yeah. No, don't round your decimals. Go out at least 2 decimals. You can go out more if you want, but at least 2. Oh, I did the square root of 69.5 squared plus 14.86 squared. Like I did that all at once. Does that make sense? Rather than having to write down those two separate. Any other questions on the hypotenuse? Okay, how do I get my angle? Okay, tangent inverse equals, or of what? Do I put a negative in there? No. We're looking at side lengths only. We're not looking at where they actually are right now. Okay, so this angle right here is 77.93. None of y'all are red-green colorblind, are y'all? Y'all can see?
See, are you colorblind?
I know, and okay. All right, so how far am I going to go to get here? I'm going to do what? From 180, because if I went all the way here, that'd be 180 degrees. Does that make sense? Okay. Right. Okay. This is 180, and then you got to go that much more. This amount isn't the same as that amount. This is where to go to 270. Does that make sense?
See, minus 180. Or whatever your
You do whatever this angle is, you add it to 180. Yeah, because you go 180 and then you go a little bit more. So what angle would I actually put right here? And that is my answer. And that one. You got to put both. Y'all see how that works? Any questions? Yes. Any questions? All right. So, did they give you the vectors? No. So, what do we got to do? Where is our origin? Okay. So, see if you can draw two separate vectors. So, two lines. See if you can draw them like separately. Yeah, like draw them separately. Well, you've got two vectors in the picture, right? Separate them into one picture for one vector and one picture for the other. See if you can do that first. No, just draw them as two separate pictures. Put one vector over here and one vector over here. Just
On both sides of the axis?
two pictures. Just like on the last one, we had two vectors and we did a picture for each of them. Draw a picture of each vector. No. You got two to. Okay, well it still goes on the coordinate axis somewhere.
Oh my god, it's not a triangle?
Just draw your two vectors.
Yeah, go ahead. I have no clue.
Try and draw your two vectors separately.
I don't see
All right, someone go draw one of the vectors. Okay.
Don't throw the marble. You don't get it, so. Don't test me.
Wait, what? This axis. Okay, I'm quiet.
don't like it make sense, but
No. No. Not quite.
Okay, can I do it?
Someone else go try and draw a vector.
I'm gonna try to do 6.
Okay?
Is that?
Is that right for the 16 one? Why in that quadrant?
because it's going that direction.
From the origin, where is it going?
Left.
Up and left.
I
Okay? Someone go draw the other vector. There you go. That's it.
What?
I've heard it. I'm going.
They're not the same.
I figured out.
I know. Not the same. It's not the same. This is fun.
Okay. So, look in here. Do we have an actual triangle?
No.
We don't need a triangle. How far right do we go? Do we go any up or down? So do you need the 0? Because it has an angle. It has a 30-degree angle. It goes up 30. But B is just straight to the left. Do y'all see how that works? So how would I figure out my vector, what it would be in rectangular form? So see if you can find your R and your U. It sure is.
So, for the 10 one, U is 0 or U is not? Is that what you're saying?
For what?
You
U is 0. U isn't, it doesn't go up or down any, so U just doesn't exist. Is that what you were asking?
So, rectangular form, if you add on the negative 23.86 or 1.8.
Oh, I don't know. Jason says yes. Do you agree? Okay, so how do I find the resultant? All right, what would you get? What form is that? Okay, but we gotta find polar. What does polar look like? Your magnitude at an angle. I don't know what the little symbol is, so I just say at. What quadrant does this go to? If you look, Does it look like if these are two things that it's going to end up over here somewhere on the left side? One's going strictly left and one's going left and up. So should it end up left and up? Yeah. So that's one way to tell if you've done it correctly. One's going left and one's going left and up. So when you add them together, it should be left and up because those are the only directions you've gone. And ours is left and up. $23.86 squared plus 64 is not negative.
You do negative 282.
No, I got 28. Okay, I got it. That's what I got.
What do you get for your H?
But then you have to subtract it from the Oh, okay.
Oh, the angle? Oh, I haven't done that yet. That looks right. I mean, that sounds about right. Okay, any questions on the hypotenuse? The magnitude? Okay, what about the angle? Yeah, you get 18.54 whenever you do tangent inverse, and then you got to subtract it from 180. Any questions there? Yeah, if you're just a little bit off, that's okay. That'll be okay. Oh, the answer is both of these. Good. That make sense? Okay. Look at another one. Yes, you still are drawing two separate pictures. I personally draw a picture every time.
I was thinking black. This is thinking black. Yeah. So I would say two erasers.
Okay, be quiet, be quiet, be quiet. All right, will someone go draw one vector on a quadrant by itself? Sure. Do you agree with their pictures? You agree? They should look basically the same, just put on a coordinate plane. What do you mean? You put the... No, you have to put it in the second.
That's not both every time.
Do you agree with that one? Oh, thanks. Now, do you agree with it? Okay. Do you agree with that?
I did that.
Yeah.
What? Yeah, that doesn't help.
Teachers, would you please allow the white squad cheerleaders that are participating in the scholarship signing to report to room 114 at this time? Also, I have a couple of announcements. All dandelions need to report to room 127 for 7th hour. Also, again, track practice for today has been canceled. Thank you.
Do you agree? Any questions on that part?
Oh wait, that's the before they're added.
Yeah. No, that's after. That's like what they're added to be. Well, one. You got what? Any questions on it in rectangular form? What quadrant is this picture going to be in? So when I get my angle, do I use it or do I change it? Does that make sense? That's, you just have to look at the picture. Do what? We'll get there.
Oh, you're leaving our mind.
You took the square root twice.
Where did you see that? I messed up on the recording.
I made it. It's 58. Did you use 58?
Oh, alright.
Wait, quick. That's 45.64, A1.1.
That's in polar form.
Okay, so we do it now. Okay.
Oh, someone didn't understand how to get the polar part.
Oh.
You find your H, which should be 45.64, I think. Let me make sure. Yeah. And then at 81.86 when you use your tangent. Any questions on that? It's exactly what the book has. Anything you're confused about still? So what's different about these compared to other problems?
You have to make your picture.
You have to make your own pictures, yeah. Any questions on these? No, you don't have to.
But when you're right,